So let's try this example. So x squared plus 4 dy over dx equals sec squared y. Okay, so first of all, let's see whether we have a first order differential equation. So let's rearrange it in this form. Py dy over dx equals q of x. So let's see where we can rearrange in this form. Okay, so we have x squared plus 4 dy over dx equals sec squared y. So I'm going to take the sec squared y term to the left hand side, and I'm going to bring the x squared plus 4 to the right hand side. Okay, so we're going to have 1 over sec squared y dy by dx. So I brought the sec squared y term to the left hand side. Okay, and let me bring the x squared plus 4 term to the right hand side to give me 1 over x squared plus 4. Okay, and remember, in trigonometry, 1 over sec is cos. Okay, or the reciprocal of cos is sec, which means that 1 over sec squared will be cos squared. So I could rewrite this as cos squared y dy by dx, and that is equal to 1 over x squared plus 4. Okay, so as you can see over here, I have an equation of this type. Py dy over dx equals q of x. So py, that function is cos squared y. Qx, that function is 1 over x squared plus 4. Okay, so this equation that we have here is a first order differential equation. So we need to use separating the variables to find its solution. So let's go to step number 1. So remember, in the screenshot, step number 1 is to write your y and dy terms on one side, write the x and dx terms on the opposite side. So back to the paper and pen. So cos squared y dy, I'm going to keep that on the left, and 1 over x squared plus 4 dx, I'll keep that on the right. Okay, so step number 2, the next step. So back to the screenshot quickly, integrate both sides to find the solution. So over here in step number 2, if we integrate both sides, so we need to integrate cos squared y with respect to y, and we also need to integrate the right hand term, 1 over x squared plus 4 with respect to x. Okay, now we need to think about both integrals on the left and on the right, and let's use our integration knowledge. Okay, so remember, in an integration video that I did, and I'll provide a link to that video in the description below. Okay, I went through a flowchart that I created in order to help you recognize which integration method to use for which integral. Okay, so let's test that out on the left hand side firstly. So we need to integrate cos squared y, so let me call that star, and let's do star as a side calculation. Okay, and remember, to integrate cos squared y, we need to use the double angle formula for cos. So remember, to integrate sine squared or cos squared, always think about the double angle identity for cos. Okay, so let's use cos 2y, that is equal to 2 cos squared y minus 1. So this is the double angle formula for cos that we need to use to integrate cos squared y. Okay, so if I rearrange this, we're going to have cos squared y, and that is equal to cos 2y plus 1 divided by 2. Okay, so instead of integrating cos squared y, let's integrate cos 2y over 2 plus 1 over 2 instead. Okay, so let's do that as a side calculation. So let's integrate cos 2y divided by 2 plus 1 over 2. Okay, so if we integrate cos, remember the integration of cos is plus sign, so we're going to have plus sign 2y divided by that 2. Okay, so if you divide by that 2 together with this 2 will make it a 4. Okay, so we're going to have sine 2y over 4 for the integration of this first term. And if we integrate half, that is y over 2. Okay, so this is what you should have when you integrate the left-hand term, cos squared y, with respect to y. How did we integrate cos squared? Remember, to integrate cos squared or sine squared, think about the double angle formula for cos. Okay, so star is finished. Let's focus on double star. So let me name the right-hand integral double star. And let's do that as a side calculation also. So for double star, let's integrate 1 over, okay, x squared plus 4 with respect to x. So in this case, I can rewrite 1 over x squared plus 4 as 1 over x squared plus 2 squared. Okay, as 2 squared is the same as 4. Okay, and let me remind you of this result. Remember, to integrate any expression of the form 1 over x squared plus a squared with respect to x, the result is 1 over a tan inverse x over a add c. Okay, so in this case our a term is going to be 2, so let me make a note of that here. And bearing in mind that a is 2, let's use the standard result in order to help us with this integral. So we're going to have 1 over a, our a is 2, so it's 1 over 2, tan inverse, okay, x over a, which is 2, okay, so that completes the integral of double star. Okay, and let's use these results from the side calculations in this main calculation over here. So for star, we integrated that as a side calculation. We had sine 2y over 4 plus y over 2. So let me make a note of that here. So sine 2y over 4 plus y over 2. And that is equal to, and on the right hand side, the integration of 1 over x squared plus 4, I've named that double star. We found the solution to that integral over here, and we had 1 over 2 tan inverse x divided by 2, and I like to add c on the right hand side. Okay, so this is our general solution. Okay. However, we're not finished because we've been given these values. Okay. So y is pi over 2 at x equals 2. We can use these values here in order to work out this integration constant. Okay. So let's use these values that we've been given. Y is equal to pi over 2. X is equal to 2 to calculate the c value. Okay, so y is equal to pi over 2, x is equal to 2. So in this case, let's substitute them in. So we're going to have sine 2 of y, which is pi over 2, okay, divided by 4, plus the y is pi over 2, divided by 2, and that is equal to 1 over 2 on the right hand side, okay, tan inverse x, which is 2, over 2 add c. Okay, so we can make some cancellations here. So this 2 and this 2 can cancel. The 2 over 2 can cancel here, giving us 1. Okay, so if we simplify further, this is what we're going to have. So in this case, we're going to have sine pi is a standard result, so sine pi or sine 180 is 0. So we're going to have 0 plus pi divided by 2 is the same as pi over 4. That is equal to inverse tan of 1. So inverse tan of 1 is pi over 4. So that's a standard result. So pi over 4 times half is pi over 8. Okay, plus a c. And when you rearrange this, c will therefore be pi over 4 minus pi over 8, which is pi over 4. Pi over 8 rather. Okay, so you're going to get pi over 4 minus pi over 8, which is pi over 8. Okay, so let me put the c value being pi over 8 back into this general solution to give us the particular solution. So in this case, if I replace the c by pi over 8, our particular solution will then be sine 2y over 4. Okay, plus y over 2. And that is equal to 1 over 2 tan inverse x over 2 plus c, and c we found as pi over 8. Okay, so this is our particular solution to our differential equation in question. Okay, so if you've been given values for x and y, you can use these values or these conditions in order to calculate the value of your integration constant. Once you have that value, you can replace that back into your general solution to find your particular solution. Okay, so that completes this example over here, example 2a. So x dy over dx equals 2 plus dy over dx. Okay, so first of all, let's rearrange this and let's try and see whether we have a first order differential equation. So let's try and rearrange this in order to get py dy over dx equals q of x. So let's investigate and try and see whether we can rearrange this equation in this form. So in this case, I'm going to collect all of the dy by dx terms to one side. So if I take this dy over dx term to the left hand side, I'm going to have x dy by dx minus dy over dx, and that is equal to 2. So I'm going to keep the remaining term on the right hand side. Okay, now what I'm going to do next is let me take a common factor of dy over dx. So if I take out a common factor of dy over dx, we're going to be left with x minus 1, and that is equal to 2 on the right hand side. Now let me take x minus 1, this term as a whole, to the right hand side. So in this case, I'm going to have dy over dx, and that is equal to 2 over x minus 1. Okay, so as you can see over here, this equation that we have is of the form py dy over dx equals q of x. So once again, we have a first order differential equation. Okay, so since we have a first order differential equation, we need to use separating the variables. So here is step number 1. So remember, in the screenshots, the y and dy terms appear on one side, x and dx terms appear on the opposite side. So in this case, I'm going to keep the dy on the left hand side, and I'm going to take this dx term to the right to give me 2 over x minus 1 dx. Okay, so step 1 is complete. Okay, and the next step and the final step is step number 2. So in step number 2, remember on that screenshot, integrate both sides. So let's integrate both sides. So let's integrate the left hand term, dy, and let's also integrate the right hand term, 2 over x minus 1 with respect to x. Okay? So first of all, let's integrate the left hand side. So integration of 1, okay, with respect to y is y. So we just have y on the left hand side. And if you integrate 2 over x minus 1, okay, so remember our flow diagram, the integration flow diagram. This integral that we have is a fraction, and since it's a fraction, let's try f primed over f, okay? So in this case, f primed over f is going to work because when you differentiate your denominator, okay, the answer is related to the numerator. So if you differentiate x minus 1, you get 1. 1 is a constant, and we have a constant in the numerator, okay? But you could just as well take that 2 as a common factor. So before I integrate, let me take the 2 as a common factor, giving me 1 over x minus 1 within the integral. And if we integrate this term, we're going to have 2 ln modulus of x minus 1 add c. Okay? And we haven't finished because we've been given some values for x and y. So y is equal to 1, x is equal to 2. We can use these values to work out the value of the integration constant c. Okay? So y is equal to 1, x is equal to 2. When I do the replacement here, I'm going to have y, which is 1. That's equal to 2 ln the modulus of x, which is 2, minus 1, add c. Okay? So if I simplify this further, 1 on the left is equal to, now I have the ln 2 minus 1, so 2 minus 1 here is 1, and ln 1 is 0, so you're going to have 0 plus c. So c therefore is 1, so that is the value of your integration constant. So if I replace c is equal to 1 in our general solution, we have our particular solution. Okay? So let me continue on the reverse. So therefore, the particular solution, so that will be y is equal to 2 ln modulus of x minus 1 plus c being 1. Okay? So y is equal to 2 ln modulus of x minus 1 plus 1. Okay? So that completes this example. So that finishes this example, and unfortunately that ends the video also. So I hope you found this video enjoyable. I hope you found it useful. If you did enjoy the video, a like is very much appreciated. Do related practice questions, and I hope to see you soon. Thank you.